Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning in a Young's double slit experiment, the source of light consists of wavelengths in the range 3000 to 8000 Armstrong. The distance of the screen from slits is 2 meter and distance of separation between the two slits is 10 to the power minus 3 meter. We need to find out the wavelengths in the visible range, that is from 400 nanometer to 700 nanometer, present at a position that is 10 to the power minus 3 meter from central maximum. So in question 1, we have established a relation between y, that is the distance of point P from the central maxima, and the path difference, and we have obtained this relation y is equal to d by d multiplied by path difference. Now, it is saying that at the position we are having maxima and it is equal to 10 to the power minus 3 meter from the central maxima. So value of y, it is given to us, that is 10 to the power minus 3 meter, and capital D, it is 2 meters, and small d, that is the distance between the slits, it is given as 10 to the power minus 3 meter. So these are the values that we can interpret from the question. And we need to find out that at this distance, what will be the wavelength of light that is present. So we need to equate this path difference with the condition that is given, and for maxima, path difference can be written as n lambda. So again, we can put all the values. So y is equal to capital D upon small d multiplied by n lambda. And from this, I can find out the value of lambda. So lambda will be equal to y times small d divided by capital D multiplied by n. We can use the values that are given to us. Y is 10 to the power minus 3, small d is 10 to the power minus 3, capital D is 2. So I can write 10 to the power minus 3 multiplied by 10 to the power minus 3 divided by 2 multiplied by n. That will come out to be 10 to the power minus 6 upon 2. And I can solve it further as 0.5 multiplied by 10 to the power minus 6 upon n. And I can also write it as 5 multiplied by 10 to the power minus 7 upon n. So this is the value of lambda that is present at a distance 10 to the power minus 3 from the central maximum. Now the value of n will decide that what can be the value of lambda. So for n is equal to 1, lambda will be equal to 5 multiplied by 10 to the power minus 7, and that can be written as 500 nanometer. Also, for n is equal to 2, lambda will be equal to 2.5 multiplied by 10 to the power minus 7, and that can be written as 250 nanometer, and so on we can find out. Now they are saying that we need to find out the wavelengths in the visible range only. So from 400 nanometer to 700 nanometer, there is only one wavelength that is present, and that is equal to 500 nanometer. So we can write in the visible range, the wavelength present is 500 nanometer, or we can write it as 5000 Armstrong. And that's the answer for this question. Keep learning, keep practicing, keep excelling.